Assalamualaikum and salam sejahtera. Today we'll continue our lecture for EBT 449 Environmental Friendly Polymers. Okay, for this topic, okay, we will learn about the manufacturing technologies for biopolymers. So you guys need to know first, okay, do you think that, okay, even if you are using biopolymer, does the manufacturing technologies to prepare or to produce, okay, products based on biopolymer are still the same if compared to the conventional polymer, or else we need a new technologies to manufacture the end product based on the biopolymers. Okay, let's see. Okay, manufacturing methods. The manufacturing rules all show certain fundamental similarities, which the major difference depending on whether a thermoset or thermoplastic biopolymer is to be processed. Okay, means that, okay, the technologies to produce, okay, product based on biopolymer are still similar to the conventional polymers, but it is depending whether it is a thermoset or a thermoplastic, because the manufacturing for thermoplastic or thermoset is different method have been used to process these materials. Thermoplastic materials must be melted and then formed into the shape of the finished articles. The melt is then allowed to be freeze and the manufacture of the article is complete. Okay, for the thermoplastic, first we need to melt the materials, and then when the material is in a molten stage, then we can make or form it into the desired shape that we are required. Okay, once the desired shape have been achieved, then the material need to be freeze or cool so that the shape can took place upon when it is being cooled. The process can be repeated but not indefinitely, since even though the raw material is only melted, there is no irreversible chemical reaction take place. Damage can still be done to the molecular structure of the melt materials. So for thermoplastic, okay, we know that it is a reversible material by means that we can melt, okay, and shape it again and remelt the material and shape it again. But however, even though there is no irreversible chemical reaction take place, but damage of the material can still occur due to the molecular structure of the polymer melt. Okay, so this is the process or manufacturing process for thermoplastic. So you have your thermoplastic, and then your thermoplastic is then being melted, okay, under a certain condition or temperature where the material needs to be exceeded the melting temperature of the materials. Okay, once the melt have been achieved, then you can shape the materials into your desirable product. Okay, and then after your material have taken place according to the shape that required, then it need to be cool so that the metal can solidify or harden to the desired product. Okay, subjecting the melt to a higher shear condition, for example, by pumping it or stirring it violently, can cause the molecular change to break. Okay, so when the melt, okay, have is subjected to a high shear or by pumping it violently, okay, it can cause damage to the molecular change. The result of this is an unqualified decline in the mechanical properties of the solid polymer, as well as unqualified change in the nature of the flow or properties. Okay, once the molecular chain, to break have been damaged, okay, the result is that you will have a poor mechanical properties as well as the flow properties of the polymer melt. Okay, so let's say that you have your equipment, processing equipment, okay, and then you subject it to a high shear, okay, the molecular chain tends to break. Okay, once the breaking of the molecular chain have happened, okay, it will reflect it to the end properties of the materials. The condition is intermittent operation process such as injection molding are less damaging to polymer melts and most problematic in continuous process such as extrusion, particularly in process where the extruded is stretched such as film and blowing. Okay, so if you are using injection molding, it is considered as an intermittent operation. Okay, and then injection molding will least damaging the polymer melt. However, a continuous process or equipment used such as extrusion or extruder, okay, it will cause a more serious damage or molecular chain break to your polymers. Okay, the limitation factors for processing condition for biopolymers are the same as the fossil origin materials. The degradation at the upper limit of temperature and shear and lack of homogeneity at the lower limits. Okay, so if you are processing biopolymer, okay, the limitation, okay, condition to process this biopolymer are still the same as the fossil materials. Okay, so you have your TM, let's say you have your melting temperature. If you operate, okay, above the melting temperature, okay, the upper limit of the temperature, okay, it will start to degrade. Okay, however, if you process it lower, okay, than the melting temperature, the homogeneity of the material is less, and it will lead to a unhomogeneous, okay, material, and the properties will be affected. However, these limits are somewhat more tightened draw at the upper limit of the material, so it's more considered towards the upper limit of the biopolymers. The result of exceeding this upper limit are degradation of the polymers, resulting in molding defects such as wet line, discoloration, or a strong odor in the final products. Okay, when we are discussing about biopolymer, processing of biopolymers, okay, the main concern is when we process them above their degradation temperature or else the melting temperature. Okay, when we process them above this temperature, the material started to degrade. Okay, once the material started to degrade, okay, it will show defects such as weld line, discoloration, or strong odor in the final product. The route for manufacturing thermoset articles is slightly different. Thermoset components shall not react to form polymers until they have been formed into their final shape. Okay, so you know that you already know for conventional thermoset, okay, before the material, okay, have taken place, you has taken place for the desired shape, okay, you cannot put your hardening additive. Okay, when you put your hardening additive, okay, this material started to cure. Once it cure, it cannot fulfill or being shaped into the desired shape. As a consequence of this, unreacted thermoset still consider of short change molecules and therefore are much less viscous than the thermoplastic polymer melts. This phenomena opens up a number of interesting production routes. It's now become possible to inject low viscosity liquid thermoset through reinforcing materials to produce long fiber composite articles. For example, vehicle spanner. So, okay, because of this low viscosity, okay, you can incorporate with a reinforcing materials, okay, so that you can use into an injection molding machine. Okay, so it is suitable or it can be used inside a injection molding. Okay, and then additive. As we know that additives are very important. Okay, when we intended to manufacture a certain product. Okay, additive helps, okay, or aid the processing of the material as well as enhance the properties of the desired materials. When processing a fossil origin polymer melt, the operator has the advantages of having access to a wide range of processing aids and property improver. These additives are usually added in a small quantity and with the exception of the biocide, are unlikely to have any effect on the gross biodegradation of the polymers. Okay, for biopolymers, okay, the main concern is that the biodegradation of the product. So when you add additive inside biopolymers, okay, the main element or the main consideration that needed to take is the biodegradation of the product. Therefore, the amount of additive used, okay, incorporated inside these biopolymers need to be well planned so that it will not jeopardize the biodegradation of the biopolymers. However, the selection of additive for biodegradable polymer system should be undertaken with care to avoid compromising the biodegradability certification of the finished articles, such as these SETCO standards. Okay, so this SETCO standard, okay, is a document, okay, or standard that will help the manufacturer or processor to determine how much additive are needed to be added, or what is the limit of additive that are required, so that the biodegradation of the biopolymer is not jeopardized. Okay, plasticizer. Plasticizer increase the flexibility of the polymer's product and also decrease the viscosity of the polymer melt. A role also played by lubricants. In terms of biological origin material, epoxidized soybean oil is used as a plasticizer and heat stabilizer in PVC production. Epoxidized linseed oil and tall oil are also used as PVC plasticizer. For biopolymer, the additive, okay, used are more likely to be origin from nature or else a natural additive. Okay, for example, okay, when involved in PVC production, okay, bio additive or additive from nature that can be used, okay, as a plasticizer is such as soybean oil or as epoxidized linseed oil. It may be that this material will also find application in the biopolymer. Recent work described that the use of liquid CO2, sometimes described as supercritical CO2, injected into the melt. This required the addition of mixing stage to the end of extruder or molder barrel, but significant reduction in melt viscosity and melt temperature are reported. Okay, so supercritical CO2 or liquid CO2 will help, okay, to will help to reduce, okay, the melt viscosity and melt temperature when involved in processing the biomaterials or biopolymer inside an extruder. Lubricants. Okay, internal lubricants perform a similar role to that of plasticizer. External lubricant include material that function as mold release agent. Okay, so we know that lubricant, okay, is used, okay, mostly as a mold release agent or to avoid the friction, okay, when processes the material inside the equipment. The obvious sustainable origin material release agent are waxes such as bee wax, carnauba wax, and rapeseed oil. Okay, marketed by Vichy Limited as Biofarm. Okay, so there are alternative for biopolymers or biomaterial additive for mold release agents such as wax from bee wax, carnauba wax, and rapeseed oil. These materials are effective mold release agent, but care must be taken to avoid overdosing the mold surface. This will have the consequence of producing grease bloom of the surface of the molding. Okay, so when you use mold release agent, the main concern is that you cannot use the materials or the additive more than it's supposed to be. When you are overusing the material, the consequence will be the product produced will have a greasy bloom on the surface of the molding. Okay, and then the DIN SETCO lists the following processing auxiliaries as certified composable up to level of 10%. Okay, so when you use this additive, okay, it is only can be used up to 10% according to the DIN SETCO. Okay, so the material is benzoic acid or sodium benzoate, uric acid amide, glycerol monostearate, glycerol monolate, natural waxes, paraffin waxes, polyethylene glycol, and stearates. Whilst the following can be included up to 49%, but if you use this material or additive, okay, it can be used up to 49%. This is the importance of this SETCO because this SETCO will determine how many percent of the additive that can be used so that you will not jeopardize the biodegradation of the materials. Okay, colorants. Some colorants may be objected to due to inherent but environmentally acceptable substitute, or either mineral or vegetables origin are increasingly available. This deco lists that the following mineral colorant are certified compostable up to level 45%, 49%. Okay, for colorant, okay, you may use this type of colorant such as carbon black, iron oxide, graphite, titanium dioxide, and you can use it up to 49% of this colorant without compromising the biodegradation of the materials. Flame retardant. The chemical used to reduce the flammability of polymer are commonly chlorinated and brominated compound, sometimes with autonomy-based synergies, used as flame quencher and phosphorus compound to improve the char strength. Okay, commercially or conventionally, okay, chlorinated and brominated compound are used as a flame retardant. Okay, these are regarded as undesirable due to the perception of their toxicity. Okay, alumina trihydrate released in water of hydration when subjected to heat and hence limit the propagation of the combustion. However, it is added in a large amount to the polymer, maybe around 50 to 60%, and may at the upper limits of the addition compromise the biodegradability of the particles. Okay, so when you use okay, flame retardant up to 60%, you may compromise the biodegradability of the particles. Blowing or forming agent. Liquid CO2 admixture can be used as a forming agent for injection molding and extrusion. For PU biosystem, water can be used as a forming agent exactly as in fossil formulation. So water can be used as a blowing agent, okay, exactly as the fossil formulation. Crosslinker. At the moment, crosslinker are usually the same formulation as those used in fossil origin thermoset formulation. Thus, articles made from bio-origin thermoset are not always 100% biological origin. However, some crosslinker agents such as the formaldehyde used in cashew nut origin for phenolics are biological in origin, being made from wood alcohol. So, when we talk about crosslinker, okay, most crosslinker that are used in thermoset, okay, are not 100% biological origin. So, okay, to make it more biological, okay, biological origin additive crosslinker need to be used or implemented. Okay, an alternative is such as cashew nut origin phenolic, which are biological in origin, which is made from wood alcohol. Filler. Filler are the most commonly used additive. Fine mineral powder filler are added as nucleating agent in a small quantities, maybe around 1%, to limit the size of crystalline structure. This is of limited application with biopolymers, limit the degree of crystalline structure formation. Okay, despite of reinforcing, okay, filler are also used, okay, to create the nucleating or to create the crystalline structure. Okay, and then based on the Dean's Tech list, the following filler are certified compostable up to level of 49%. Okay, this is a type of filler that you can use up to 49%. Filler and reinforcement for biopolymers. Filler in plastic are, as the same suggests, compounded with the polymer to fill out the plastic, thus allowing less of the more expensive polymeric material to be used to produce a large volume of moldable resin. Okay, filler currently used, there are two types of fillers. First is reinforcing and another one is non-reinforcing. But both reinforcing and non-reinforcing filler are used, okay, to be a part of the polymer to reduce the cost. Okay, as we know that, okay, matrix polymer matrix are more expensive compared to fillers. So by incorporating filler inside the matrix, you can reduce the cost of producing in the product. Okay, whereas the volume of the matrix or polymer matrix can be reduced and can be replaced by the filler. This suggests that fillers are combined with the polymer merely to take space, but they can be used to impart improved properties to the resin. This reduces article costs by improving material properties, allowing less material to be used. The use of natural fiber filler for plastic can be tracked back to 1907. when Bakelite utilized wood flour as a filler in thermosetting phenolic resin to create a material that to this day is known as bakelite. Okay, so bakelite, the material bakelite, okay, is being manufactured or invented, okay, back at 1907. Okay, when bakelite utilized wood flour as a filler in thermoset phenolic resin. The field of wood-filled thermoplastic compound can be classed as relatively mature, as there are a number of wood-filled products that are currently available on the market. Example, calcite, which is wood flour filled polypropylene, tracks and advanced environmental recycling technologies, which are 50-50% ratio by weight wood flour filled polymers. The metric polymers used for these materials are propylene, high density polyethylene, and low density polyethylene respectively. Work have been published that investigates that the use of other natural fiber, excluding wood, for use as a filler and or reinforcing material in plastic. Example, sugarcane baggage filled thermoset polyester, short fiber jute reinforced polypropylene, straw reinforced polypropylene, knaf reinforced polypropylene, flax reinforced polypropylene. So, despite of wood, there are many other fillers that are already been used, okay, to be a part of the polymer matrix, okay, such as sugarcane, short fiber, straw, knaf, and flax. It can be seen that there exists a variety of options open to biopolymer manufacturers and processors who wish to reduce the article cost. So when you incorporated fillers, okay, you can reduce the material cost. In much of in much of the work, the reason cited for the use of natural fiber as a filler or reinforcement is that they are first biodegradable, renewable, and environmentally friendly, low in cost, abundant, possess good specific properties. Okay, this is why okay natural filler are being used to be incorporated in biopolymer because of its biodegradable, is a renewable resources and environmentally friendly. Last, it is a low in cost, is abundant and possess a good specific properties. Belsky, Raymond, and Gassan performed a literature review into the use of thermoplastic reinforced with wood filler. This uncovered 26 pieces of work. Okay, so the use of wood filler have been reported in many articles. Okay, and then for Belsky itself, okay, he already written about 26 articles related to wood fillers. The conclusion to his work here that the major problem associated with the use of wood filler are high level of moisture absorption and that fact that untreated wood fiber are inherently difficult to cope with the biopolymer. Okay, this is the major problem when you are using natural filler such as wood filler. Okay, as we know that wood filler is a natural resources. Okay, the hydroxide elements, okay, inside, okay, the wood filler is very high. This is the reason why it is really easy to absorb moisture. Okay, and then how to counter this problem? Modification have to be taken into place, okay, to reduce the hydroxide group, okay, and then they reduce the hydroxide group so that the moisture absorption can be reduced. Okay, meanwhile, okay, due to this hydroxide, okay, we know that most or commonly due to the polarity. Okay, and then when the polarity of the filler and the matrix are different, okay, the homogeneity, okay, or the homogeneous of this blend cannot be compatible. Okay, the latter factor equates to composite to have a low tensile strength. Okay, this is due to the different polarity between the filler and the matrix. It may be necessary to modify the plastic to develop strong covalent bonds with the polar fibers. The coupling of the fiber to the matrix can be achieved through the use of compatibilizer such as malate anhydride, nickel peroxide, or chlorosulfonate polyethylene. Okay, due to the different polarity, okay, to enhance the polarity, between between the filler and the matrix, okay, you can use a coupling agent to improve, okay, the intersection addition between the filler and the matrix. Okay, okay, that's all for today. Thank you very much.